Good afternoon, students. Today in this session we are going to see about the nodal voltage method. That is the dual of mesh analysis method. So far we discussed mesh current method by using different loops, 2 loop method, 3 loop method, in equation based how to solve it, and in matrix method how to solve it. Everything we have discussed so far. And nodal voltage method procedure we have discussed in the previous class. Based on the procedure, today we are going to solve one problem, 1 or 2 problem. Then we will see one by one. Here also, like mesh analysis, there are 2 ways. One is equation method, another is matrix method. Here also in nodal analysis method we can solve the given problem to find the unknown voltages value by using the equations or directly by using the matrix method. Both the methods yields the same results. So today we will start with nodal voltage analysis for the 3 minutes. Yes, let us take this problem on the nodal analysis. In nodal analysis, first you draw this given diagram. So consider this diagram and solve by using the procedure what we have discussed in the previous class. Okay. First, what is the first step? Find the number of nodes, including reference node, active nodes and reference nodes. So how to find it? First, consider starting from this is one junction. I am going to take this as one junction. I am going to see whether this can be taken as a node or not. So check the procedure. What is a node? Node is a point or junction where 2 or more branches are connected. Let us see how many branches are connected here. In this junction, this 1 ohm resistor, that is one branch, and 2.5 ohm resistance, another branch, both are connected to the same. So the condition is satisfied. How many branches are connected? 1, 2. Totally 2 branches are connected, so that it can be considered as a node. So I am considering this as a node, and I am going to name this as node number 1 as discussed. Similarly, come to the next meeting point. Next, I can get to this point. This is a meeting junction. Okay. Then how many resistors are there? There is how many branches are connecting to that node? You can see in this point junction there are 3 branches are connecting. 1 ohm, 2 ohm, and another one 3 ohm. So condition satisfied. 2 or more branches to be connected to a junction, so that we can name it as a node. So condition is satisfied. So this one can be considered as node number 2. Similarly, move to the next junction. That is this point, where here also the condition is satisfied. That is, this branch and this branch are connected to the same node. As the condition is 2 or more branches to be connected to name it as a node, this is satisfying. So this can be connected as 3. And the next junction, this is the junction where all maximum number of branches are connected, and this can be considered as a reference node. So now we can say there are 4 nodes, 3 are active and 0 is the reference node, and the potential of this node is 0, and the potential of this one can be taken as V1, and here V2, and here V2. So with respect to the reference node V0, which is equal to 0 always, since it is a reference node, we are going to find out the unknown voltages value V1, V2 and V3 by using nodal analysis method. Yes, as I already said when starting this class, this is the dual of mesh current method. There is current in mesh. Here it is voltage. There is a resistance. Here it is a conductance. There is a current here voltage and here it is a current. So accordingly, when you see, we can write the base equation for the method is G matrix multiplied by voltage matrix is equal to current matrix. G, what is G? Conductance. What is G? Conductance. G is equal to what? A reciprocal of resistance. You can see n number of resistance are in the given diagram. Resistance is used to find the value of conductance G by taking simply a reciprocal. So how many nodes are there? Active nodes 1, 2, 3. So there are 3 cross 3 matrix for the conductance. So what should be there? We have right G11, G12, G13, G21, G22, G23, G31, G32, G33, and the unknown voltage value V1, V2, V3, which is equal to what? I1, I2, and I3. You can compare this one. Why we are saying dual of mesh? There was resistance, but here it is a conductance. There was current in this place for the mesh. Here it is voltage. There was voltage in this place for the mesh, but here it is a current. That is why it is called as mesh. Dual of mesh. Okay. Now our duty is to find the values of all the known values from the given diagram. What are the known values? G1 what is? G22 what is? G33 what is? G12 is what? G13 is what? And similarly G23 is what? G32 both are same. I1 is what? I2 is what? And I3 is what? This is the first most step of the solving the problem. Very, very important step. By finding these values, simply you can put it in the matrix calculation so that you can find the values. Yes. G1. What is G1? 1 that you mesh the dual of mesh. 1 indicates first node alone. What is the first node? This is the first node, right? In this first node, you have to look at what are the resistances. Not resistances, it is a conductances connected. This 1 ohm resistor, this 2 ohm. So what is the total value connected here? 1 ohm and 2 ohm. So what is the conductance connected to that point? It is the resistance. So conductance means what we should take? We need to take the reciprocal. What is the reciprocal of this one? 1 by 1. And what is this next one? 1 by 2.5. You should take 1. What will be the total value? 1 by 1 is 1. 1 by 2.5 is 0.4. Totally what is the value? 1 plus 1 by 2.5. What is the value of 1.2? Similarly, G22. What is G22? 2. What are the elements connected to that node alone? 1 ohm, 2 ohm, 3 ohm. So what is the total value? 1 divided by 1 divided by 2, and 1 divided by 2. Students, please calculate these values and let me know. Similarly, G33. In G33, what are the 2 ohms and 4 ohms? So you can 1 by 2 plus 1 by 4. Similarly, next conductances G12, that is non-diagonal elements. What are the non-diagonal? D12, 1, 2, there are 1, 2, R12. First node and second group, so the common resonance. Here, first node and the second node are the common conductance. What is the first node? This is your first node and this is your second node. What is the common thing here? This 1 ohm. Take the reciprocal 1. Here, then 1, 3. 1 and 3, is there any common resistance conductances? Nothing is there. So put 0. Then 2 and 3, 2 is there. So 1 by 2. And there we assume, not assumed the current direction. Based on those current directions, we have put plus or minus in this. But here, defaultly, value you put negative for all the non-diagonal elements. Non-diagonal elements. 1 divided by 1 minus 1. It is 0. Here it is minus 1 by 2 is equal to minus 0.1. Understood? Yes. I1. What are the pending elements in that equation? I1, I2 and I3. I1 means you should consider only I1. In the node 1, what is the total current? What is the total current? Apply KCL, Kirchhoff's current law. What is Kirchhoff's current law? Yes. Kirchhoff's current law plays a role here. What is this? Say it is defined as in a common junction. Algebraic sum of current entering is equal to algebraic sum of current leaving. This is a statement for the KCL. You apply the same here. You can find the value of I1 and I2 and I3. So apply here sum of current entering. Algebraic, how many currents are entering? I can see this arrow indicates this current is moving towards this node. So this is the entering current. How much it is? 4 ampere. At the same time, in this node, how much value of the current is going away from this node? That is the next important thing. Away from the node is 3 amps. Incoming is 4, away is 3. So incoming 4, away minus 3, which is equal to what? 1. Understood? Similarly, you find the values of I2 and I3. I2, when you see about node number 2, what is incoming from this node? Towards this node, the 3 amps is coming. At the same time, from the 2, the 4 amps is leaving, moving away from that node. So 3 minus 4. Incoming is 3, outgoing is 4, which is equal to what? Sorry, minus 1. Understood? Yes. Come to third, I3. I3 say take this node. You can see the 4 amps is coming inside. And at the same time 4 amps is going outside. You are earning 1,000 rupees per day. You are spending all the amount earned on that day for some other purpose. Incoming is equal to outgoing. So what is the value? Incoming is 4, outgoing is 4. The total value will be 0. Understood? Yes. Now we have the values of all the values. Yes, sir. We forgot to put the values of G1, G2, G3. Put that value 1 by 1, 0.4, which is equal to 1.4. Here it will be 1 by 1, plus 1 by 0.5. This one is plus 1 by 3, 0.33. So what will be the value? 1 plus 0.5 plus 0.33. So it will be 1. Now we know the values of all the elements except the unknown voltage values. Put all these values in the matrix equation. We know what is that value? 1.4, 1.8, 0.75. Remaining values -1, -1, 0. Sorry, this one should be 0. And then -0.5, -0.5. You know, all these values are calculated. Now I would like to actually also need to count it. What are that values? 1, -1, 0. 1, -1, 0. Yes. Now we have done almost. Now simply calculate by using the Cramer's rule. Students, I rub it out. To solve. Print the procedure. Hope you can understand. Now I know the formula. Cramer's says a rule. V1 equal to L1 divided by L, V2 equal to L2 divided by L, and V3 is equal to L3 divided by L. So you know the procedure to calculate L. Yes. What is then? Determinant of your conductance matrix. 1.4, 1.8, 0.75, -1, 0, 0, -1, -0.5, what is this value? This is called del. This is called what? Del. Del. Can you please check the values? Calculate by using the calculator, or simply solve and tell me the answer. Okay. Yes. Please check. Similarly, you find the values of del 1, del 2, del 3, so that we can substitute that into V1 formula, V2 formula, and V3 formula. Del 1. What is del 1? You can see del 1. Del 1 is nothing but asynchronous current is the first column of the matrix, conductance matrix here. What is this? This is the current. Remove all the first column. Put these values 1, -1, 0 here. Then what will come? 1, -1, 0. -1, 1.8, -0.5, 0, -0.5, 0.75. Similarly, find the other values. What is del 2 now? I am going to remove all the second column and replace the second column by your current matrix value. What are the current values? 1, -1, 0, 0, -5, 1.75. First column already we have 1.4, -1, 0. Similarly, what is del 3? You can easily say remove the third column and replace that third column by the current matrix. When you change 1, -1, 0, remaining values 1.4, -1, 0, -1, 1.8, -0.5, del 3. This is del 3. So now, tell me the answers. For del 1, del 2, del 3. Yes? What? Yes. Right? Yes. 0.665. Okay. Similarly, you tell me the values by calculating. Tell me how to how to find. Tell me the values. Yes, one by one you tell me. Del value substitute 0.665. Similarly, tell me what is del 1 and del 2 and del 3. Del 1 and del 2, del 3. Yes. And tell me. Del 1, del
0.275.
yes, whether it is positive or negative. Positive only, correct? That is very important. When you do smaller mistake here, even the sign differs means it will give you a wrong results. So the value will be 0.275. Yes.
Del 2
Found? Yes, del 2 how much you are getting?
minus 0.28.
Yes, minus 0.28. You can compare these two, see, almost equal. But the sign, what is the sign here and what is the sign there? So, when you are doing calculations, you do with very intense calculation. Okay? Similarly, tell me the third value.
Minus 0.2.
Minus 0.2 is the answer. Now, we can see all values we have. Put it in the formula directly. V1 and V2, V3. That is, what is that? Del 1 divided by del 2, del 2 divided by del 3 divided by del. So now we have the all values from the given circuit diagram calculated. So put it in the formula directly. What are the denominator values which is common for all the voltage values, node voltages? That is 0.665. Numerators 0.275, minus 0.28, minus 0.2. So, put it in the calculator. Tell me how much for 0.275 divided by 0.65. This will be around 0. How much? 4. 4 to 1. Exactly. Minus 0.4 and this one is minus 0.3. 0.31 something will be right. All you very important thing is you have to put the unit of all the voltages, voltage. Okay, that are the very important things in terms when you are studying about the everything. Units are very important. Yes, this is the actual procedure. And one of the very simplest problem, introductory problem in nodal voltage method. So, coming classes, we are going to solve the same problem, but not directly going into the matrix. We will go to the matrix after writing the equations for the each and every node. In this problem, we have directly written the matrix and calculated very simply. But writing the equation, and from the equation we can go for the matrix. Then the same procedure can be followed. Understood? Yes, the same way. Now, as I already said, nodal voltage method and mesh method are called as dual of both. Yes, same. Why? Already I explained. Anyhow, so, to know about your understanding level, I just going to draw one circuit randomly and let me know how many nodes are there and how to write the matrix equation for that. To take this diagram. take this one and tell me how many nodes are there. Tell me how many nodes are there. Nodal voltage method. Yes. The first most thing is you should see current source is there or voltage source is there. It is a voltage source. This is a voltage source. This is a voltage source. Right? But nodal voltage method, what we need? We need a current source. So what we can adopt here? Yes, we can convert the voltage source into the current source. Voltage source into the current source. So converting the voltage source into current source is not at all a matter. It is very easy that we can already discuss it during the starting of the first unit. So how to do it? Voltage source to current source and current source to voltage source. I will make the voltage source to current source transformation. See, what is the voltage source? 10 volt. And what is it? When the resistance connected in series with this 11 volts minus 10 volt. I want to convert this voltage source into the current source. How to convert? Simple Ohm's law. What is the Ohm's law? V is equal to I into what I need? I. So what is I value? V by R. So what is the voltage value what we know here from this element? 10 volt. What is the resistance value given? 1 volt. So 10 divided by 1 equal to what? 10. That is ampere. 10 ampere. What is the value? 10 ampere. So now the voltage source is converted into the current value, which means current source. The symbol, this is the symbol, positive or negative sign for the voltage source, and for the current source, what is the symbol? You know, arrow mark. Is upward direction or downward direction or right direction or left direction? Since the positive is at the top and the negative at the bottom, the resultant symbol should be pointing towards the positive direction. What is the positive? It is in the top. So you have to put the arrowhead at the top. So this is the symbol for the current source after conversion. So what is this value? We have calculated 10 amps. And current source should be connected in parallel with the resistance. What is the resistance value? The 1 ohm resistance, internal resistance. Now we can see that current source is converted into, voltage source is converted into current source. It's the same. You have to apply here also. You have to apply here also. When you apply here, what will come? 10, 15 volts goes to divided by 4. So how much the value of the current? I equal to 15 divided by 3.7 something. So this one should be upper side. In parallel, what is the resistance? 4. Total value 3.7. Similarly, for this one, 5 divided by 5, 1. Replace that. Now replace all the voltage sources with the current sources which are converted by using the voltage to current source transformation, and apply the method what we discussed previously in today's class. Same procedure. The only difference is in the previous problem it was given directly everything, but in this problem instead of current sources, voltage sources have been given which need to be converted into current source, and only we can apply the Then only we can apply the nodal voltage method. Okay students, I hope you understood this session. Practice more problems so that you can get more clear about the nodal voltage method. Thank you.